Hello everyone, this is Group 123, and we are about to present our research project on the real-time vector-based image search using AWS services. And here's the outline of our presentation. Due to the rapid growth of image data in the internet, it is required that we have an efficient retrieval in cloud environments. As traditional keyword-based search has limited semantic understanding, and they are unable to perform semantic search. And manual annotation on the images is extremely costly and is not scalable for large datasets. So a scalable and semantic image retrieval solution is required. The objective of our project is to design a cloud-native vector-based image retrieval system. It should support text-to-image and image-to-image search. By enabling the real-time ingestions to OpenSearch, the images are searchable in the OpenSearch with low latency. And to improve the cost efficiency using serverless architecture and adaptive S3 storage classes. And here's the overall system architecture of our projects. So we upload the images through our API to perform searching, and the AWS Bedrock will convert the search request into vector, and then we retrieve the images using the similarity search. We have customized a storage tier to optimize the storage clause in and the architecture support real-time search and scalability and cost efficiency. And this is a deep dive of our real-time ingest to search pipeline. So the images are stored in S3 and they will be indexed in the OpenSearch before the users start to search. And the queries submitted by users will be processed and matched using vector similarity. So we prepare the images and put them in S3, and we store the data into the DynamoDB and perform the indexing through the OpenSearch pipeline to OpenSearch. So users are now able to query the data from our OpenSearch, and the OpenSearch return the similar images. For the vector embedding, it represents the image and queries in a semantic database. We have used Grok to generate image description and OpenSearch to index the vector for similarity search. For the retrieval mechanism, our systems support both text-to-image and image-to-image retrieval. So the text and also the images are converted to vector, and then they will be searched in OpenSearch. So the results are returned based on the vector similarity scores, so we can handle both query types in a unified way. And we are able to support more scalable and effective than keyword-based search. And here's the AWS service and the implementation choice for the compute resources. In our system, we have used Lambda, and the reason why we use Lambda is that it is charged per request and is lightweight processing. Moreover, it is highly scalable compared to EC2 because, as we all know, the EC2 takes a long time to scale up. So they are unable to. It's extremely hard for EC2 to handle the spikes in traffic. And for the storage, we have chosen S3 because it's able to store the images, and most importantly, it is able to customize the storage class for optimization. And it's worth noted that our user interface demonstrated late in the later section are hosted in S3 with the static HTML files. For data, we have used both OpenSearch and DynamoDB. We use DynamoDB for the fast key and value lookup, and it supports some simple query requirements. And then we use OpenSearch for the full text search and the vector search. With our adaptive storage tiering, it reduces storage costs using Amazon S3 tiering. So the storage class is selected based on the access recency. For security and governance, it is important that multiple AWS services interact with image data and metadata. For the IAM role for Lambda, it is customized and customized per services as suggested by AWS. We have also enabled the CloudWatch for the monitoring. And for the evaluation, We have prepared over 1,000 images, and the workflow will include image upload and description generation and also vector indexing, and finally, the keyword-based retrieval. And here are the metrics we used, and we will explain it in the later slides. For the ingest to search performance, we have compared the time of the image being uploaded to S3, and they are able to be searched in the OpenSearch. We have compared the performance with DynamoDB and OpenSearch, and expected that the OpenSearch allowed for semantic and image search after vector embedding. However, DynamoDB only supports text search. For the keyword response time, we have used K6, the framework for specifically for load testing. And the result is surprisingly that the OpenSearch spends almost half of the time, and the average response time is much better than DynamoDB. Moreover, we have discovered that there's a cold start in the Lambda execution. As captured in the event log, it is observed that there is a init duration in the Lambda execution. So when a function is invoked for the first time after a period of inactivity, or there is a burst in traffic, it will introduce the cold start time. And by enabling the provision concurrency, we are able to solve this problem. However, it will introduce more cost. And for storage and cost optimization, we adopt a 4T approach for cost optimization for infrequent access. So the idea here is that the triplet storage will lead to longer retrieval time. We have configured the storage class in both lifecycle policy and our S3 tiering Lambda. And our project has some limitation. Instead, we use a small dataset in the evaluation, and a serverless application like Lambda may introduce cold start time. In the current storage tiering, consider only the access frequency. For the future work, we are planning to expose an interface for users to upload their own images and index them to OpenSearch, so that their own images will be searchable online. And we'll explore more advanced storage tiering strategy. To conclude, we have proposed a cloud-native vector-based image search system to support text-to-image and image-to-image search. In the following demonstration, there will be two parts. The first part is to demonstrate the functionality of our pre-built user interface. The second part is to demonstrate the real-time indexing and searchable images. So let's start with our text search. By default, it will search from OpenSearch directly, and it supports semantic search. So here we can see some images, all related to red compact SUV. But for DynamoDB, since there's no support for the semantic search, so we should make the keyword short and simple. The idea here is to search for exact match in the description field, and there's no semantic search. So let's move on with the image search. So we have already prepared some images here, so let's try with trunk demo 1. By clicking the search images button, it will search directly from the OpenSearch, and there's some result from the returned from the OpenSearch. So let's move on to the real-time indexing flow. For simplicity, we will use the folder inside the demo. Here we have two images here. Let's try to upload them here. After uploading the images, it will immediately save to DynamoDB. Yes, can be seen here. The two images are saved here, the carriage demo 1 and carriage demo 2. And then after saving to DynamoDB, it will be indexed to OpenSearch directly. And here is the result. Carriage demo 2, and here's the embedding for the description, and the second one is the carriage demo 1. So let's try with image search again for the upload the images. Since the images is already indexed into our OpenSearch, it will be immediately be able to search under our algorithm. And this is the end of our presentation. Thank you.